Hello subscribers, welcome to Stematics tutorial. In this video we are going to see two main important theorems in semester 1 statistics, karl Pearson quotient of skewness and Bowley's quotient of skewness based theorems, which you can expect for long answers.
So here we are having an important theorem, prove that karl Pearson's quotient of skewness lies between -3 and +3. So in previous video we have seen what is the skewness and absolute relative measures and absolute measures we have seen. So in relative measures we have three formulas. From that we are taking quotient of skewness, karl Pearson quotient of skewness formula. So we have there like two formulas are there. From that we are taking the second one. So karl Pearson quotient of skewness. So here we have SKP2 equal to 3 into mean minus median by standard deviation. Now consider modulus, suppose mod mean minus median equal to, so everyone knows what is the formula of mean, 1 by n summation I equal to 1 to n xi minus median we are having. So this median only I am just modifying the formula, 1 by n into n median I am writing like this. So is there any problem with this? If I cancel n and n, I am going to get again median. So this median I have written 1 by n into n median. So what is the common in these two things? 1 by n is common. So let us pick up outside the mod. So 1 by n mod, leftover value is here summation I equal to 1 to n xi minus, and here the leftover term is n into median, because 1 by n we have written outside as common. So n into median. Next, substitute the values 1 by n, summation I equal to 1 to n. For I equal to 1 this becomes x1 plus summation means sum of all the values or sum of all the observations. So x1 plus for I equal to 2 x2 plus so on up to how many values will get? N values, xn minus n median. So n median I am writing as it is. So how many medians are there here? N medians are there. Remember this, n medians are there. Next, so as we are having here n medians, I want to subtract each observations from, so here I will put a bracket so that there will be no confusion. So from each of this observation I am going to subtract one median. So it becomes now 1 by n x1 minus median. So one median is finished. Left over how many are there? N minus 1 medians are there, and here n minus 1 observations are there, plus x2 minus median. So like that for n observations I can do the same thing, xn minus median. So next, now 1 by n as it is, I can notate this in the form of summation. Summation I equal to 1 to n xi minus median. So I'll start a bracket here, I'll end here bracket. So this is what we got now. 1 by n modulus of summation I equal to 1 to n xi minus median. So on the left side we are having mod mean minus median, right? So now I want to get the summation out of the mod. So what will I get? Less than or equal to symbol. This equal to symbol changes to less than or. So mean minus median less than or equal to 1 by n summation I equal to 1 to n mod xi minus median. Is it clear? So what did I do here? Just I have taken the summation outside the mod. So it becomes the sign equal to sign becomes less than or equal to. Now what does this formula represent? This formula represents median. Mean deviation. Mean deviation formula is xi minus median or xi minus you can take mean deviation about median, mean deviation about mode also you can take. So here we are having median. It represents the mean deviation. So mean minus median, mod of mean minus median less than or equal to, this formula represents mean deviation. So MD I am writing here, and we have a note point always. The mean deviation is less than or equal to standard deviation. Mean deviation is less than or equal to standard deviation. So I am substituting here the same thing on the left side, mean minus median as it is. So which is less than or equal to mean deviation, where mean deviation is less than or equal to standard deviation. So now I can replace it with this standard deviation SD. So how we denote the standard deviation? We denote the standard deviation with sigma. So mod mean minus median less than or equal to sigma. Now I want to bring the sigma to the left hand side. What will be remained on the right hand side? Tell me. So mod mean minus median divided by sigma. If this comes to the left hand side, it becomes division less than or equal to. So there is nothing left, so we can take 1. Now you always know that mod x less than or equal to 1 if it is there. If I want to write outside, if I want to remove this mod, so what will I get? Minus 1 less than or equal to x less than or equal to 1. So now I want to remove this mod. So what will I get now? 1 less than or equal to mean minus median divided by sigma less than or equal to positive 1. So next I want to multiply 3 on both sides. Multiplying 3 on all sides. So what we will get here on the left hand side? Minus 3 less than or equal to 3 into mean minus median divided by sigma less than or equal to 3. So Why I am doing this, I'll tell you in the next step. So finally we got minus 3 less than or equal to 3 into mean minus median divided by sigma less than or equal to 3 we got. So what does this formula represent? 3 into mean minus median divided by sigma is what? This value represents what? So we have seen SKP2, which means coefficient of skewness is SKP2 equal to 3 into mean minus median divided by standard deviation. Now can I replace this term with SKP2? Yes. So we will get now minus 3 less than or equal to SKP2 less than or equal to 3. This is what? Karl Pearson's coefficient of skewness, right? So therefore you can say that coefficient of skewness. So where does it lie? The Karl Pearson quotient of skewness lies between minus 3 and plus 3. Therefore the statement is proved. Karl Pearson quotient of skewness lies between minus 3 and plus 3. So second statement, prove that Bowley's quotient of skewness lies between minus 1 and plus 1. So previously we had did Karl Pearson quotient of skewness lies between minus 3 and plus 3. Karl Pearson quotient of skewness is a relative measure of skewness. Now Bowley's quotient of skewness is also a relative measure. Once you can go back to the previous video and check over the absolute and relative measures of skewness. So now we are going to the proof. Bowley's quotient of skewness is given by SKB equal to Q3 plus Q1 minus 2 median divided by Q3 minus Q1. So now Q1, Q3 are the quartiles, first quartile and third quartile. Median also you can take it as Q2, which is the second quartile. So SKB equal to Q3 plus Q1 minus 2 Q2 divided by Q3 minus Q1. So we can put this aside. Next, suppose let us assume small a comma small b are two non-zero numbers. So non-zero numbers, then let us take an identity mod a minus b less than or equal to mod a plus b. Because suppose if I take, for example, no need to do that in proof, but just for your understanding I am saying this. Why this identity is true or not? Let us check here. Let a equal to 3, b equal to 5. I have taken like this. So I am going to substitute here. Mod of a minus b minus 3 minus 5 less than or equal to 3 plus 5. Is this correct or not? We are checking now. So 3 minus 5 is minus 2. Minus 2 if you apply mod you will get 2 less than or equal to mod of 8. Mod of 8 already it is positive, we can write 8. So now which is greater? 8 is greater and the sign also refers to 8 only. So this identity is true now. You can use that. So this is the rough part, no need to do here. Just for your understanding I have explained. Now you bring this term to the left hand side. What you will get? A minus b divided by mod a plus b less than or equal to. So here nothing is left, you can take 1. Now let us assume a equal to q3 minus q2 comma b equal to q2 minus q1. Substitute here. What we will get? We are going to see now. So q3 minus q2 minus of b place, in b place I have written q2 minus q1 divided by mod of q3 minus q2 a plus b q2 minus q1 less than or equal to 1. Now solve this. So in the numerator q3 minus q1 minus of q1 minus into minus plus, so plus q1 divided by q3 minus q2 plus q2 minus q1 less than or equal to 1. So any cancellations possible here? So minus q2 plus q2 is, we can cancel. In the numerator we are left with q3 minus q2 minus q2. So both are minus only, you can add that and you will get 2q2 plus q1 divided by q3 minus q1 mod less than or equal to 1. Now, so you can bring this out of mod, right? So and you can write it as here in numerator and denominator we are having mod. You can replace it with one mod, no need to write two mod. So whole mod you can write q3 minus 2q2 plus q1 divided by q3 minus q1 less than or equal to 1. So just now in previous theorem we have discussed, if mod x less than or equal to 1, if you want to remove this x out of the mod, you can write minus 1 less than or equal to x less than or equal to 1. Here also same thing. So I want to remove this out of mod. So I can write like minus 1 less than or equal to q3 minus 2q2 plus q1 divided by q3 minus q1 less than or equal to plus 1. Now what does this represents? q3 minus 2q2 plus q1 divided by q3 minus q2, which represent this formula SKB equal to q3 plus q1 minus 2q2 divided by q3 minus q2. Same here also we are having the same thing. q3 is there, minus 2q is also there, plus q1 is also there, divided by q3 minus q1. So same formula you can replace it with SKB. So minus 1 less than or equal to SKB less than or equal to plus 1. Therefore, which means Bowley's quotient of skewness lies between minus 1 and plus 1. So we have proved this theorem.
Hope you liked the video. Please subscribe, like and share the video. Thank you for watching.